Welcome everybody, and good morning, good afternoon, and good evening, wherever you are. Thank you for attending or watching the YouTube recording for this Areopa webinar. This is our 104th session in season 6, and today Patrick Schiefer will tell us about test automation for connected systems. But first, we, as usual, do some housekeeping rules. As everybody knows who attended more often and frequent, your mic is muted. We agreed with Patrick that we do a Q&A session at the end. So if you have questions, put them in the question or chat box, and I will ask them later on when Patrick has done his whole session. This webinar, as all the other ones, is and will be recorded and will be published later on YouTube on our Areopa Webinars YouTube channel. And if you look there, please like, subscribe, share our videos so it does the normal thing and the good thing for the YouTube algorithm. If you want to be more and even get more information from Areopa, you can subscribe to our newsletter, and here you have a link to the subscription of this newsletter. For our agenda, this you can find also on our website from Areopa. We have already planned some extra or follow-up sessions. April 28th, Scrum, Stoicism and System Thinking by Ivan Bilanov. May 5th, System Integrations by Benito Ramirez. May 26th, Sustainability Functionality by Neil McGovern. Marked on Magical Mermaids by Jeremy Viscas on the June 23rd. And now, as last planned at this moment, July 7th, Killer Prompts by Miguel Azevedo. So if you want to subscribe or register for these sessions, please go to the webinar website and where you can register for these sessions. And if you want to be a speaker on a certain topic, please contact us so we can make a connection for your session and put it into a planning. As usual, we want to thank our sponsor for enough for making and sharing this GoToWebinars platform so we can use this kind of broadcasting. And then I now want to change and make Patrick a presenter.
Hello, I hope you can see my screen now.
Yes.
Thank you. Welcome to my webinar about test automation for connected systems. I'm Patrick Schiefer. I'm working for Cosmo Consult. I'm working there at the moment for Cosmo Alpaca as a DevOps engineer, and I'm also a Microsoft MVP for Business Central. Today, I want to talk about test automations for connected systems, and therefore I have collected some topics. First of all, I will talk a little bit about goals and introduction, different test strategies, and also about code architecture and different approaches for testing in AL. When we talk about a Business Central installation, we have quite a lot of things which surround Business Central, like Power Automate, WebShot, Power BI, external inventory systems, EDI solutions, external databases, and other APIs. And Business Central is the connecting part of this all systems. So we have quite a lot of things which speaking to Business Central. When we code something, we want to test such things. So every developer has the challenge to test these connections. So what are the actual challenges? So Business Central environments getting more and more complex. We have an update cycle from 6 months. Every 6 months we get a major update. Every month we get a minor update in the SaaS environments. We don't have time for full integration tests on every update cycle. We somehow, in very old projects with legacy systems and so on, very often the key users are not working for the customer anymore. So we have a missing knowledge for full integration test. And also we have a problem, a lot of work for maintaining the test plans. Our goals are reducing the time for testing. We want to test fast and fail early if we have any problems. We want to structure our code for test scenarios. So it starts already at the code structure and not at the test scenario. We still want to keep our code simple and stupid. This is the KISS principle from the clean code principles. And we also want our customers to update PC as fast as possible. We don't want to use the full update window from, I guess it's 6 months at the moment. I'm not totally sure what the full update window is at the moment. And of course, everything we do is about quality. We want to increase the quality of our systems. When we think about these all connections, there are different types of connections. We have APIs, which are using REST and JSON. We have the older SOAP connections, which is using XML, mostly XML, and web services, so HTTP. We have different file services like OneDrive, SFTP, and so on. And we have business events which are connected to Power Automate, for example. And all these types need different all these type of connection need different test approaches, or at least a good architecture to test these things. So what are the test strategies we have? So when we talk about the Business Central, we have at least 3 different test strategies. Of course, there are more and more test strategies around the world and the PC world, but I'm only talking about 3 today. So we have system testing, end-to-end testing, and unit testing. And every of these test strategies have different approaches and different advantages and disadvantages. So let's start with the system testing. When we talk about system testing, we talk about PC production environments which are connected to, for example, a live web shop. This is a real live scenario for testing, which means we are testing with real data, we are testing in real systems, and if it works in the real system test, it will work. But we have some disadvantages. First of all, it's time consuming. You cannot test everything, because if your testing is including posting, you can do test postings in live environments, and that's the most disadvantage. And we have very high advantage, which is that we have the highest functionality assurance, which means you test the real scenario, so it means if it works, it will work also for later. So this system testing is not really possible during development, because often you don't have the live systems already. Testing happens in production environments, which means you have unpredictable runs, because maybe someone has changed data in the live system and your test is not predictable anymore. So one test may work, the next test may fail because some data has changed and you have to adapt your changes to the actual data. Very similar to the system testing is the end-to-end testing, which just differs in the type of environment you take. So you have a PC sandbox environment and you have a sandbox web shop, for example, and you test the code quality and the functionality, and you have a very high assurance. But you also have the problem, you have to have a ready-to-use release, which you can deploy to a sandbox, and then you test the ready to release. So also here you're testing in realistic environments, but not live environments. You're also testing across different systems, and compared to the system testing, it's also very time and knowledge consuming, because you have to know how to test. And of course, the environments have to be configured. So you have to have a sandbox running, and you have to have a sandbox web shop. And also here, you have the unpredictable runs, because someone might change data and your test won't work anymore. So when you think about coding, the only real test scenario which makes sense is a unit testing. So we test without any running system, and we test small chunks of code. Even if the test is necessary to test the whole process, we test not the whole process as one piece, we test just the small chunks of the process and test everything. We have high predictable runs because we use the same data for every run, and we use, for instance, fake data to ensure the data is always the same. But what we're not testing here is the connection between the two systems. So we're testing only in Business Central and not testing the connection between the systems. So if we want to do unit testing for connected systems, we have to think about code architecture. So let's see how an outgoing API call looks at Business Central. So when we want to call an foreign system API, we have usually a code unit which is processing the data and then sending and get data from external systems. For example, here I have my test. I have my processing code unit, which is getting via the REST client some data, and then it processes the data and does something with the data. And the test is very simple. We just test if the response is correct. So when we test, we have here the same test, and we are testing, as we have seen, just calling the processing code unit. We have one problem, which is that the foreign system or the third-party system is somehow acting sometimes differently. We will get some error messages, for example, that in my weather forecast, the weather forecast is not returning always the same data. And sometimes it works and sometimes it not works. So let's see how this is looking in the code. So as we have already seen on the slides, we have here our get weather forecast with the REST client, and we have a table where we add this weather forecast to pass the data. And in the test, we are getting this, and then first of all we test if the date is correct. In most of the cases this will work, I guess, but we are also testing the return value if the return value is correct. Does not make any sense here because it might change because it's a forecast. So when we have a look at Business Central, so we have here the weather forecast, and we run this selected. So everything in the code looks correct, and what we are seeing here, it looks like we are getting an out and timeout because the foreign system in this case is not even running. And so when I want to test this, I'm depending on the foreign system, so I cannot test this if the foreign system is not running or something like that. So we need a solution how we can test without relying on a foreign system and without relying on others, and still get predictable results and still get a high quality. So if we want to do this, there is another code architecture we can introduce. But first, let's summarize this test. So the test is depending on another system. So as we have already seen, it may work or it may not work. If the other system is down or somehow internet connection fails or something like that from your development environment, then the test is not possible, and it may block you in your coding process, so you cannot proceed to finish your coding while this test is failing. So how can we change it? We add just another layer of abstraction, and we have now a code unit which is processing the data, then an interface which is abstracting everything, and then we have one code unit which is getting or sending the data. this means now we have the possibility here in the middle section to define where we get our data from. So our processing code unit is only connected to the interface, and the interface is getting the data. So for our live scenario, we remove the direct dependency of our code to the external internal system. And as I already said, we split it up a little bit and abstract everything. Here we have our interface, which now gives us the possibility to get the weather forecast. And I will show you in a few seconds in the live system. And also we have an implementation for this code unit, which is just doing that the get from the REST client and gets the data from the interface. So the most of the code is just the same. We only have now we have still our function, our procedure, which is the get weather forecast. And here we have an implementation of the code unit, which is a global variable. We have it here. And then we get our weather forecast using this implementation. And when we have a look at the initialize function, we have two overloads, one without any implementation and one with an implementation. And if we don't give any implementation, we just use the standard implementation, and we also only initialize the implementation once. So now, when we just call this, it will use the standard implementation. The standard implementation is just using REST client.get, and this might still fail because the test automation server which is used here is not online. But I have now the possibility, when we go to the tests, to create my own implementation of get weather forecast. And when we have a look here, we have the possibility in the code unit mock get weather forecast to define our own function to get the weather forecast. In this case, I'm just using http content.create and create my own content, which is just a fake data. And now if I want to test this, I'm relying on getting this data. And if I have changed something in my logic, which might break this, I will still be able to test as long as I'm using this mock. I also set the status code and so on. I can also have different mocks. So if I want to have a code unit which is simulating a timeout or something like this, I can also create a second code unit and just set other fields on this response. So for example, I can set error messages and so on, and then I can simulate different error messages. Yeah, I can also return a case in which is not valid and so on. So I can simulate different scenarios. And in my test, I initialize the weather forecast using the mock get weather forecast. Then I call the get weather forecast, and then I can actually execute this and don't get any error anymore. So let's see in the web client. In the meanwhile, the first test failed, but I can execute the second test and just run it. Okay, the first one still failed. Looks like I messed it up a little bit. Yeah, the first one failed because here I don't using the mock. I forget to set the mock here. So this one is still using the HTTP request and sending actual data, but I don't use the mock here. So here I have the problem that it's still not working. So if I wanted to get it working, I have to initialize it using the mock. So I can execute it. Now when I run, it is successful because I've simulated a running system, and now the test is successful, and I can test the whole process around it, but not the actual system. I've also added a little bit advanced example. Here's the same test. I want to create an order. I have a page extension where I can place an order in a foreign system. So I have a third-party system where I want to place an order. I have a code unit which is called place order, and here I'm creating some JSON, and I sent this JSON and so on, and I'm using the implementation here again. So I have also a interface to place this order, and I'm using this here to actually send the order to the third-party system. And also here, the implementation of the place order is just creating an HTTP content and a REST client, and send to this REST client some data. Since the third-party system is offline, I cannot test it really, but I can have different tests using mock. So what kind of tests do I have? I have here some tests for a normal order, a successful order, a failed order, and also have a test if the JSON which is created is well structured. So when we have a look at the test, I have different test scenarios. First one is just placing an order, like it's done in the page. The second one is using a successful API call. The third one is using a failure API call, and the third one just creating a JSON structure, and we compare if the JSON structure is well formed. So if you have a look at this different mocking code units, we have one mocking code unit which is just creating a HTTP 200. We have one mocking code unit which is creating an HTTP 500, and one mocking code unit which is just creating the JSON file for this order. And I have here another function which is giving me the possibility to get the JSON out of it. So let's have a look in detail. For example, the failure test, because we are getting an HTTP 500, we are doing an asset error here, and we expect this to fail. If it's not failing, then we would this test would be unsuccessful. Here we are also just executed the successful test. We don't have any asserts here because we are just testing if the test is successful. And in the third place, we are generating some purchase order header and some lines for the purchase order. And then we place the order, and with the get JSON, we just return the JSON and check if the generated JSON is in the right structure. This is a way to handle outgoing APIs. So if we want to call a foreign system, for foreign systems of outgoing APIs, we also have now in BC26 the HTTP client handler, which is a very similar solution, just using an integrated handler function in AL. Why I don't use it? 2 points. The first of all is I've used this kind of architecture for a long time, and it works since BC16, and it will still work in the future. The HTTP client handler is new. That's why I didn't use it now. Maybe I will use it in the future, but also the mocking solution which I use is very flexible and can also be used for other use cases, not only for HTTP client handlers. It can be used for every test where you want to fake data. Okay, so let's summarize this a little bit. When we use mocking, we have predictable tests, absolutely predictable. Everything you do is working every time you execute it the same way. It only fails if your code is broken, so we are not depending on any other system. We can fail early, so the test is failing in your web client, and you can also execute a local Docker environment, and you can still use this test, and you can fail very early. And if third-party systems are down, you don't block your process. So if your CI pipelines are executing these tests and you rely on third-party systems, maybe your CI pipeline won't complete because your tests are failing based on the dependency. So without any dependency, your CI pipelines won't fail here. So for inbound APIs, it's more or less the same. So a normal inbound API looks like we are having an API page. We are validating some input and processing some data, and then it will be saved in the table. So if we want to test this, we have also different possibilities. And the first and easiest possibility is using Postman. But first of all, let's have a look at the API. The API is very simple. I have created a sales order API, which has the header and lines. And as you can see here, I'm using Postman, but just let's have a look at the code. I think it's easier than using screenshots. Screenshots are only for backup here. So we have a sales order API, very easy. We have fields for number and customer number, and we have also a link for the sales order lines. When we have a look at Postman, we can just create create some sales orders here, and it's quite fast, and we can test it. But there is no real possibility to test this using test automation, because we cannot call API pages from within test automations. So how we want to test this? As I already said, you need external tools to test it. Of course, external tools also need additional know-how, and we cannot run it during pipelines. For this, we also want to restructure the code a little bit. We are now still using an API page, but we are using a custom API table. This table may be a temporary. In my use case, it is also temporary. can also be a real table, and this table is then processed using a code unit. In my case, the code unit is directly executed from the API. You can also use a job queue or something like that to process the data. If you don't need an immediate response in your API, then you can also use current job queues, which makes it much more flexible. In my use case, it's not in a job queue. I have connected it directly in the API. For this, I will switch directly into the coding. So I have here my V2. And when we have a look at the API, for the second test, I've only used the header because of simplicity. I didn't want to use a second page for lines, so I only used the header. And as we can see here, I use a source table, which is called temp sales header header, which is a table in here in my code. This table is from table type temporary, so this data is never saved actually to the database. In the triggers, I have defined some code to fill my API with correct values. So in the on new record, for example, I set the document type to order, so I only want to create orders. And in the on insert record, I am actually processing the sales order creation, and I'm not inserting it into my current table. Let's have a look at the process of the sales order. The process of the sales order is very simple. It just initializes and inserts a header, and it sets some additional values. So quite simple API. Of course, we can also test this using Postman. I now go here to the V2 of my API, and I can just post this. It's also very quite fast to use this like that. And yeah, I can execute it as often as I want. But one crucial change now is that the base that I have a code unit and this temporary table gives me the possibility to actually write test code units for it. And when we have a look at the sales order API, I have one test code unit, and it is also very simple. It just creates a customer because I want a clean customer and I want to use that here. Then I create a record inside of my temporary table, and then I process the temporary table, and using assert I check if the sales order number is not empty. So we have a sales order, and I also check if the sales order is returned when I use get using the sales order number. So I test if the sales order is actually created. And I also have a second test, which is still using a customer. I don't know why I have it here. I think it can be deleted, but I think it's because I used copy paste. And here I don't use the actual customer number. Here I use just one dummy customer number, which hopefully don't exist in my system. And when I run insert in the temp sales order header, it will not throw an error because it's just a temporary table. But when I process the sales order, when we go back here to this, the customer number, L2 customer number is validated here. So we have to check if it actually exists. So this means the process here will throw an error. We can also try via API. So when I enter invalid customer here, I will get an error. So I also get an error here. when I execute it like that. So when I go to the web client again, I can execute these two tests just by clicking again on Run Selected. The test is successful, and I can now change my code and see if it's still working. For example, when I would now go to the sales order processor and I do some changes here, and because I have done some changes, it will not be inserted anymore. Of course, this change does not make any sense, but maybe there are some ifs around here, and this will change the code flow so that it is not executed anymore. And when I go to create sales order success now and run the selected, I get an error. The error message says sales order number is empty. Why? Because the insert was not executed and I don't get sales order number. So that's a possibility to test the most things of your APIs, and this methodology works also for files. It works also for databases. You can use it almost in every scenario which you want to test. You can use the same methodology, and I don't know any scenario where you can use it. Maybe you have one. Maybe you can talk about in the questions now. But in my head, I don't have any scenario where you can't use that. So some conclusion about overall test strategy. There are always different ways to test solutions. So as I already talked about in the outgoing APIs, you have, for example, the possibility to use HTTP handler, or you have the possibility to use interfaces, or in the inbound, you can use external systems to connect to the API and test you via external systems, or you have the possibility to abstract. The most important point is, as long as you automate tests in any way, you're doing things right. So I would not rely on manual testing. And also one thing is try to abstract things for predictable results. So if you don't have any predictable results, tests are not worth a cent. And you can also throw away your tests if you don't have any predictable results. So, are there any questions?
No, you seem to be quite clear all over the place, because we have no questions at this moment. Maybe I have a question. Do we have a Git repository for it? So if somebody wants to play around with your examples.
Give me some second. Git URL origin. Yeah, we have here in my GitHub organization the repository directions in year 2024 test automations. It's a public repository, and you should be able to use it.
That's great. Thanks very much. And everybody can play around with it, what you have here just shown. And again, maybe the big importance of interfaces and uses of interfaces.
Okay.
Yeah. Okay.
Thank you everyone for joining.
Yeah. Thank you for presenting.
Have a nice day.
And I will change to me back. And again, thanks to NAF for helping Areopa and sponsoring Areopa. Thank you all to the whole Areopa team. We are a lot of people trying and making this all possible in all kinds of ways. And if you want to find us, we have a YouTube channel. As said, we have a newsletter you can subscribe to. Send us an email. We are on LinkedIn. We are on X. We are on Blue Sky. Thanks everybody for attending, and see you at the next sessions. Thanks everybody.